Welcome to the problem section for definition 3, circular functions, where we're dealing with the unit circle. A number of exercises, a couple of them might take a little longer. So use the unit circle to determine the following. For an angle theta of 135 degrees, determine sine theta. So we just read it off the unit circle, 135 degrees. We have a y-coordinate of square root of 2 over 2. And I just noticed I need to borrow the square root sign from somewhere. Square root of 2 over 2. For the cosine, we have an x-coordinate of negative the square root of 2 over 2. And of course, we don't need to worry about the r, the radius, simply because it's 1 anyway. So I'm going to put the negative in front of that. For the tangent, we have y over x. The two are equal, so we divide them, we come up with 1, but we also have a negative in front of that. There we go. For cotangent, that's the reciprocal of tangent, which of course is the same. For secant, that's the reciprocal of cosine, so it's going to be negative the square root of 2. And for the sine, that's cosecant, that's the reciprocal of the sine, so it's going to be negative the square root of 2. Paint on the side here simply means that I needed to the unit circle. Okay. The next one here, at 11 pi over 6, so we're at 330 degrees. The y-coordinate is minus 1 over 2. Minus 1/2 for the sine. The x-coordinate is square root of 3 over 2. So that's the cosine. The tangent is the y divided by the x. So negative 1 over 2 divided by square root of 3 over 2. The 2's are canceling, and we have negative 1 over the negative 1 over the square root of 3. Negative 1 over the square root of 3. Cotangent is the reciprocal of that, so square root of 3 over 1, or something with a negative in front of that. Secant is the reciprocal of the cosine, so it's 2 over the square root of 3. And sine is the cosecant is the reciprocal of sine, so it's going to be negative 2. Next exercise. Use the unit circle. So maybe I'm going to copy it down here. I think when I have my notes, I'm not going to use it that often. Sine of theta equals negative 1/2. So we're going to look where the y-coordinate is negative 1/2, and it is at 210 degrees, or 7 pi over 6. So I'm going to plug that one in. 7 pi over 6, but it occurs again over here at 330 degrees, or 11 pi over 6. Pi over 6. For the cosine, x-coordinate is negative square root of 3 over 2, so we're at 240 degrees. pi over 3. Oops, I was looking at the wrong one. X coordinate is negative square root of 3 over 2, which is 7 pi over 6, or 210 degrees. So 7 pi over 6 is one of them. And the other one is negative square root of 3 over 2, where we are at 5 pi over 6. Of course, it makes sense that the negative cosine has to be in quadrant 2 and 3, and the negative sine has to be in quadrants 3 and 4. Let's see, the next exercise says the following. Graph the unit circle using parametric equations with your calculator set to radian mode. That's a mouthful in itself, and I'm going to show you how to do that on a graphing calculator. Use a scale of pi over 12. Trace the circle to find the sine and cosine of each angle to the nearest 10,000th. So as we're in radians, we're not supposed to write down pi over something, but we're actually supposed to write down a decimal number. So let's do it. I'm going to go over to the graphing calculator. Okay, first of all, it had said, graph the unit circle using parametric equations with your calculator set to radian mode. What we first have to do is we go to mode, and we have to make sure that we're in radians. And then the next row here says that we can graph functions, and we're familiar with that, y equals parametric equations, polar equations, and I believe these are sequential or sequences. Anyway, we need parametric equations. From here, we are going to type in the parametric equation. So we click on y equals, and that looks quite a bit different from what we're used to. This is actually from me playing around with the graphing calculator one time. So there we go. Okay, I get rid of the tire rest here. I think I'm done. Okay, looks different. Both x and y are depending on the third variable t. X is cosine of t. The y is sine of t, and that simple format will give us a circle. And since the amplitude in front of cosine and sine is 1, that will also be the unit circle. We're going to go to window, and we're going to see what kind of values we want. Yep, t minimum and t maximum from 0 to 2 pi is perfectly fine. It had said give us a scale of pi over 12, so the t step is going to be pi over 12, which is in the neighborhood of 0.25, I believe. Yep, 0.26. X minimum, well, let's see what we get. That's going to be our screen. That's going to be way too small of a circle. So let's see what we get. Ooh, yeah, it's a little bit too small. Go to zoom in. There we go. Can we make it a little bit bigger? I doubt it. I think we're going to get it off the screen. Oops. I meant to zoom in, not out. Almost did it again. Yeah. Okay, so the first one here will be perfectly fine. There we go. Want to make sure that we're on z squared so that the scales are that the x's are to scale. There we go. Okay. Resolution on the graphing calculator isn't really that great, but oh well. We're supposed to trace, so click the trace button. And now don't go up and down buttons on the graphing calculator. When inside the graph, switches from one equation to another, but we only have one set of equations, so it's not going to do anything. As you notice, nothing changes. Use left and right. Left in this case actually means we're going left of 0, but our smallest t value was 0 anyway, so we're not going to get anywhere. So the only one we can use right now is go to the right. And now as we go around the circle counterclockwise, we can also go back, but only down to 0, because that's our smallest t value. Okay, we are supposed to, let's see, the idea was find sine and cosine of the angle pi over 4, which is 0.78. So let's see where we are. There it is, t equals 0.78. Our x value, which is cosine, is 0.7071, I guess we're supposed to write down. And the cosine value is 0.70. I'm sorry, the sine value for the y is 0.7071 as well, which makes sense. The two should be equal at 45 degrees, or pi over 4. The next exercise is virtually the same. Again, it says graph the unit circle using parametric equations and so on. We're already there. And then it says trace the circle to find all values of t between 0 and 2 pi, satisfying the following statement. And the following statement says that sine of t equals 1/2. So we're going to see where the y equals 1/2. Let's go forward. Nope, that increases. So we go backwards. And of course, there it is. We knew that that this here should be at 30 degrees, or pi over 6. There should be another one. Watch the y. Y equals 0.5. There it is. And t equals 2.61. Oh yeah, we're supposed to write down the decimal numbers, so 2.6180 for one of them, and the other one was 0.5236, and then from the previous was 0.7071, which actually we do have memorized. Okay, let's go back to Word and plug in our results. By the way, next time you graph, you may want to reset your calculator to the function mode rather than parametric equations, otherwise you're just going to confuse yourself. I believe I show you in a moment. So here what we had, we used the unit circle to find out what the sine of pi over 4 is, and we came up with 0.7071, and the same thing for the cosine. And the other one, where's the value for the sine of 1/2? Well, we came up with two results. It's of course at 30 degrees, or pi over 6, which is 0.5236, as well as the other results. Let's see if I can put this all in one line here. The other result is 2.6180, which is the same as 5 pi over 6, or 30 degrees. I'm sorry, 150 degrees. Okay, I just want to go back quickly to the graphing calculator and show you how do you change the mode again. So when you're done with this here, you may want to, when you click on y equals, there it's still parametric equations. Click on mode, change to function. There we go. And then depending on if you work in radians or degrees, you know, you go forth and back between the two in the mode. But now when you go to y equals, then you don't see the parametric equations anymore. You see what you normally see. All right. Okay, let's see. The next exercise says graph the unit circle using parametric equations. Again? No. I'm sorry. I'm on the wrong. I'm on the wrong problem here. The next one says, if sine of theta equals -1/3, find sine negative of negative theta. Well, sine is an odd function, so what we come up with is this, that sine of negative theta is the same as negative sine of theta. Sine of theta is negative 1/3. With another negative in front of that, that becomes positive. So we come up with 1/3. Cosine. Cosine is an even function. So cosine of negative theta is the same as positive cosine of theta, where we know what that is, negative 1/3. So there it is. Alright, and in the last two problems, it says, make a diagram of the unit circle with an angle theta in quadrant 1, and it supplements 180 degrees minus theta in quadrant 2. Label the point on the terminal side of theta and the unit circle with xy and the point on the terminal side. And then use the diagram to show that sine of 180 degrees minus theta equals sine of theta, and cosine 180 degrees minus theta is the same as negative cosine of theta. So let's just do it in Paint. Description can become pretty complicated, but once we have graphed it, it hopefully will make more sense. Let's graph a unit circle first. Ooh, that looks interesting. Circle. There we go. Alright, so there it is. Now we're going to put in certain angle theta. For example, here. So an angle theta here, and then we have the angle theta minus 180 degrees. And so I'm going to draw the angle here. So this is theta, and this is 180 minus theta, and respectively, do I just drew there's the reference angle? This one here is actually 180 minus theta. Now we're going to write on there the coordinates. So here we have x comma y, and over here we have negative x comma y. And try to grab the corner here to parentheses on the line. Okay. The sine of this angle theta here is simply going to be y. The sine of this angle here, that means actually this angle, sine 180 minus theta, is going to be y, and that's what we're supposed to show. That's actually it. Now let's do the cosine. The cosine of this angle here is x. The cosine of this angle here, so the cosine of 180 minus theta, is negative x, which is the same as negative cosine theta. And that's really what we have to show. And with that, we're done with this problem section.